So our next question is, use Euclid division lemma to show that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So for solving this, first we have to find out what are the possible a. So here let us take a is any positive integer, and we can take as 3 because here 9, so we can say that if we take b is equal to 9, then it will be big steps. So here we can take 3 because we have to find out cube of the number. So if we can take b as 3. Now what are the possible r? If b is equal to 3, r can be 0, 1 and 2 because it should be less than 3. So r can be 0, 1 and 2. So we have three cases. When r is equal to 0, our a will be, according to Euclid division lemma, a is equal to b cube plus r. So a is equal to b is 3 cube plus r is equal to 0. That means a is equal to 3 cube. This is our first a. Now in another case, r is equal to 1, then a is equal to 3q plus, here r is equal to 1. So this is our second possible a. If r is equal to 2, then a is equal to what? 3q plus 2 because a is equal to 3bq plus r. So here b is equal to 3 and r is equal to 2. So a is equal to 3q plus 2. So we got three numbers, 3q, 3q plus 1 and 3q plus 2. 3q, 3q plus 1 and 3q plus 2. So now what we have to do? The question is cube of any positive integer. So we got three numbers and we have to find out the cube. So what is 3q the whole cube? It will be 27q cube. 27q cube we can written as 9 into 3q cube. That means 9 into q is an integer. So q cube is also an integer, and an integer into 3 is another integer. So that integer we can take as m, where m is any integer. So it can be written as 9m. So a can be written as 9m. So first case we proved. Now our second number is 3q plus 1. A is equal to 3q plus 1. So again we have to find the cube of the number. A is equal to 3q plus 1 cube. So what is the cube of this one? Let us go to the identity a plus b the whole cube. The same identity we can apply here. So 27q cube plus 27q square plus 9q plus 1. Here you can use a plus b the whole cube identity, then expand this, you will get this like this. So just see the first three number. So what we have done, just take out 9 from the first three terms because here 9 is common. Now you can see that q is an integer. So this will be an integer and this will be an integer and this also an integer. So an integer plus integer plus integer is another integer. So that integer we can write as m plus 1. M is any integer. So our second term is also proved. A can be written as 9m plus 1. Now in the third case, what was our a? 3q plus 2. So if a is equal to 3q plus 2, then what will be 3q plus 2 the whole cube? The same identity you can use here. So you will get 27q cube plus 54q square plus 36q plus 8. So this you will get. If you expand 3 cube plus 2 the whole cube, you will get like this. So here also the same, you can see that take the first 3 term, you can see the 9 is common here. So if you take out 9 from all the term, what you will get? The first term you will get 3q cube plus the second term you will get 6q square plus 4q plus this 8. So just take out 9 from the first 3 term and then rewrite the sentence. So in the next step, you can see that as the step before I explained, this is integer, this is an integer, and this is also an integer. So these 3 integers together will be form another integer. So we can write this all together as any integer m. So this is 9m, then here plus 8. So a can be written as 9m plus 8. So this is our third equation. So just see the first equation and second equation and third equation. In the first equation you got a is equal to 9m. Sorry, not a cube. A cube is 9m. In the second equation, a cube is equal to 9m plus 1 because here we write the cube. So in the third equation you got a cube is equal to 9m plus 8. What this proves? This proves that for any a, that means for any positive integer, the cube of the positive integer can be written as 9m or 9m plus 1 or 9m plus 8.